This is one of the other percentage values you can be asked to calculate, and that's called percentage yield, right? And that's because in a chemical reaction, not all of your limiting reactant becomes your product. We've always been assuming that, right? Or so there are two reasons for this. One of the reasons is that you can have side reactions. For example, if you have the reaction A plus B gives you C, you can also have some of the product becoming AB. And then the second reason is that product will get stuck on the funnel that you are using. They can be get stuck on the beaker, on the sides of the beaker. And so this is two ways in which you lose product. And so not all of your product or not all of your limiting reactant will become the product. You have two different amounts. You have your actual amount, which is how much you weigh at the end of your experiment, and then you have your theoretical amount, right? So that is how much you assume you are going to that's how much you assume you're going to get, provided that 100% of your limiting reactant actually becomes your product. And so the way that we calculate our yield is using this equation. And we're going to calculate that our percentage yield is the actual yield divided by the theoretical yield multiplied by 100. So let's do an example on that. So the Acheson process consists of heating sand, which is silicon dioxide, and carbon to produce silicon carbide, which is this product. This product is a very important material in structural ceramics. And so for this specific example, we're going to work with 45 kilograms of sand. Okay, so immediately when you're reading a question, you can write down the information that they give you, especially underneath the chemical reaction. So they say that 45 kilograms of sand is processed, which is that. So underneath here, it is a good habit to list the value. And then it says that the actual yield of the product is 25.3 kilograms, right? So this, the actual yield is 25.3 kilograms. Now we're going to have to do some conversions here, because in chemistry the unit that we work with and the unit that is consistent with the formulas is in grams. Okay, so we have to do a conversion here. A short way that you can convert this into the SI unit is by thinking of how the word or the prefix kilo stands for 1,000. And so this mass is simply 45 times 10 to the power of 3 grams. And your first step will be to convert this into moles. When you are translating a mass into moles, you use this formula. So let's substitute this value. And then let's substitute the molar mass of silicon dioxide, which will be 28 plus 2 times 16. This answer will give me 750. And I want you to pay attention to the units, that because we have a grams at the top and the bottom, they cancel, and we are left with the unit of a mole, which is what we are looking for. So we have translated 45 kilograms of silicon dioxide into 750 moles. Because the coefficient or the ratio of silicon dioxide to silicon carbide is 1:1, we can immediately translate the moles of silicon dioxide into the same amount of moles of silicon carbide. And so theoretically, 750 moles of silicon dioxide should produce 750 moles of silicon carbide. So let's translate this into a mass using the same formula. So what I've done here is I've substituted the moles into the place where N was, and I've substituted the molar mass, right, for silicon carbide to be 28 plus 12, so this is 28, and that's 12 grams per mole. And now I'm going to solve for M. And this gives me a mass of 30,000 grams, which is the same as 30 kilograms. Okay, now I've converted 750 moles of silicon carbide into 30 kilograms. So that means theoretically, if I start with 45 kilograms of sand, it should produce 30 kilograms of my product. So this is my theoretical product, right? So this is my theoretical product. This is how much I should get. But according to our question, we didn't have 30 kilograms, we only had 25, and that is my actual. And so let's go back to our formula that the percentage yield is equal to the actual amount divided by the theoretical amount that you calculated. So remember, this you were given in the question, this you calculated, and then you're going to multiply that by 100. So let's substitute our actual yield. And now let's substitute the value that we calculated, which is the theoretical yield. And when we do that, we find that we have achieved a percentage yield of 84.33%. And so if you are given a percentage yield question, you have to first identify the amount that they are giving you, right? And so we converted this into moles using this equation. And then once we found out the moles of the one thing, we found out the moles of something else. So we found out the moles of SiC. And once we found out the moles of SiC, we found the theoretical yield, or the theoretical mass. And then we compared the theoretical mass with the actual mass. And then we plugged that into this equation, and that is how we achieved our percentage yield.